Hi. In the last video, we created a secure environment for our applications by adding additional security to our VPCs. In this video, we will discuss VPC architectures that can make the environments for our applications highly available. To make our environments highly available, we are going to deploy instances into multiple availability zones and load balance the requests with elastic load balancing. Finally, we'll add additional resilience to our environment by automatically scaling horizontally. AWS is built on a global infrastructure located in more than a dozen regions, including several countries in Europe and Asia, as well as Australia, the United States, Canada, and Brazil. Each region is divided up into separate physical areas in what AWS calls availability zones, or just AZs. The data centers are built in small fault-isolated clusters in these availability zones, which are typically tens of miles apart. This makes a region-wide outage less likely in the case of a natural disaster. Availability zones within a region are connected with low-latency private connections. Each region has a minimum of 2 AZs, but the largest currently has 5. Although VPCs must be contained in a single region, they can span multiple availability zones. So that allows us to deploy EC2 instances in multiple availability zones and load balance the traffic. Thus, if a single availability zone has an outage, the instances in the healthy availability zones will continue to respond to the requests. Of course, we can only be truly highly available if we eliminate single points of failure, such as a relational database. Most relational databases allow you to configure a hot standby or slave that can take over if the master is unreachable. On AWS, we can make our database highly available by deploying the slave in a different availability zone from the master. Here is a highly available VPC architecture, where we have created subnets for our instances in 2 different AZs. Note that a single subnet cannot span availability zones. We use an elastic load balancer, a load balancing service managed by AWS, to distribute the requests to the instances in different AZs. We have also separated the master and slave databases in 2 AZs. An elastic load balancer, or ELB for short, has a number of noteworthy features, including the ability to perform health checks on instances. If an instance fails a health check, it automatically stops routing any traffic to it. Originally, AWS offered a single type of ELB, which is now called a classic load balancer. You can configure it to listen for TCP, SSL, HTTP, and HTTPS. For HTTP and HTTPS, it uses a least outstanding request algorithm for routing. For other protocols, it uses simple round robin. The newer type of ELB is called an application load balancer. This allows you to route requests based upon the content of the request. For example, requests for different microservices could go to different back-end instances. In addition to HTTP and HTTPS, it has support for the new faster version of HTTP version 2. For both types of load balancers, you can terminate HTTPS at the ELB by uploading a certificate. Either type of load balancer can be used to make your environment highly available. However, not every software application is ready to be put in a load balanced environment. Many applications store some type of session or state data to know, for example, that a user has logged in or added an item to their shopping cart. If they store this data at the local file system level, then this data will be kept only on one instance and the other instances won't have a copy. So if the ELB routes a subsequent request to a different instance, the application will lose the session state. So the user may have to log back in again or have to add their item back into the shopping cart. One way to cope with this is through replication of the state data across all the instances, but this can be prone to failure of the syncing application. Another option, which is supported by ELBs, is to enable sticky sessions. In this case, the ELB uses a cookie to keep track of the instance ID that the user's request was directed to, and to continue to send other requests to the same instance. A much better option is to store the state data in a separate storage system that is accessible by all the instances. Some good choices for this are DynamoDB, a NoSQL database, or Elasticache, which uses Memcached or Redis. If we go back to our architecture diagram for a second, you can see that if AWS experiences an AZ outage, the load balancer will send all the requests to only one AZ, and we may not have enough capacity to that AZ to handle the increased request volume. The solution for this is to automatically launch more instances in the working AZ. For this, we add two more services for our VPC: autoscaling and CloudWatch. Autoscaling allows us to horizontally scale by launching and terminating instances in response to the request to load. So if our application gets a lot of traffic during the day, perhaps we will have 10 instances getting requests from the ELB, but overnight we don't have a lot of users, so maybe we'll go down to a minimum of 2. We can specify the minimum and maximum number of instances for our autoscaling group. To maintain our high availability, we should probably never specify a minimum of less than 2. When you create an autoscaling group, you will also have to define the launch configuration. This is simply all of the attributes of the EC2s that the autoscaling group will launch, including the AMI, instance size and type, security group, etc. The way that autoscaling knows when it's time to launch or terminate instances is through the monitoring service CloudWatch. You configure alarms based upon default metrics like average CPU utilization for the instances in the group and/or average response latency measured at the ELB. You could also use your own custom metrics such as memory or thread utilization by pushing metrics to CloudWatch from your EC2 instances using the CloudWatch API or by streaming log files to CloudWatch using the CloudWatch Logs agent. Autoscaling launches and terminates instances when notified by CloudWatch that an alarm has been triggered. An example of an alarm would be average CPU utilization above 70% for 3 consecutive measurements. You define a scaling policy that determines what action to take for a particular alarm. So for this high CPU utilization alarm, we could have autoscaling launch 2 instances or maybe add 50% more instances. We could scale in by configuring an alarm for low CPU utilization, like below 20%, and define a scaling policy to terminate 2 instances. Let's go through a real-world example to help you understand the concepts. First of all, I've created some new subnet to my VPC. You can see now I have subnets in both A and B availability zones. The next thing we need to add to our VPC is an elastic load balancer. You can just go under EC2s and click Load Balancers, and then Create Load Balancer. You will see you have an option of an application load balancer or a classic load balancer. For our purposes, we're not going to need to do content-based routing, so let's just choose the simpler classic load balancer. We need to give it a name, select our VPC, and we can leave the listener as HTTP. And since this is an internet-facing load balancer, we need to add our 2 public subnets, and then click Next Assign Security Groups. I already have a security group defined for the ELB, which has HTTP port 80 open to the internet. Click Next, Configure Health Check, and we'll leave the health check as it is to check the index page of our web server. Okay, we're not going to add any EC2 instances because we're going to allow the autoscaling group to do it, so just click Next, Add Tags, and then Review and Create. And finally, Create. Next, let's create a security group for the instances in our autoscaling group. Click on Create Security Group. Let's give this a name, description, select our VPC, and for the inbound rule, we're going to allow HTTP. However, we're going to restrict it to the security group for the load balancer. So type in SG and then select ELB security group and then create. Now let's go create our autoscaling group. Click on Autoscaling Groups, create Autoscaling Group, create Launch Configuration, and then I'm going to pick one of my own AMIs with just a basic web page. We'll leave the default instance type T2 Micro because this is on the free tier. However, in production, you would not want to auto-scale these instances because the CPU is burstable. So in that case, you would choose something like an M3 or M4. And we'll give our launch configuration a name. We're going to enable CloudWatch detailed monitoring, which will allow CloudWatch to record metrics at 1-minute intervals instead of the default 5-minute intervals. Next, click Add Storage. Configure Security Group. Let's choose our security group that we just created. Click Review, Continue, and then create launch configuration. Finally, let's just choose one of our key pairs and then check the box that we acknowledge that we have access to the key and create launch configuration. Okay, we finished the launch configuration, so now let's give the group a name. Select our VPC and our 2 private subnets. Now let's scroll down to the advanced details, click the arrow, and check the box Receive traffic from one or more load balancers, and select our load balancer. For the health check type, select ELB, enable CloudWatch detailed monitoring, and then click Next Configure Scaling Policies. Check the radio button, use scaling policies to adjust the capacity of this group, and let's scale between a minimum of 2 instances and a maximum of 10. Here we're going to set the scaling policy and the alarm. So for the first policy, which is going to be increasing the group size, we need to configure an alarm. So click on Add New Alarm. We can uncheck to send a notification. We can send ourselves a notification, however, if we like. And then let's go with Create an alarm whenever the average of CPU utilization is greater than or equal to, and let's put 70%, and for at least 3 consecutive periods of 1 minute. And we'll just leave the name of the alarm as it is and create alarm. Okay, now we need to do the same thing for decreasing the group size. Create an alarm. Let's uncheck the notification box and change the rule to whenever the average of CPU utilization is less than or equal to 20% for 3 consecutive periods of 5 minutes. And let's just call this low CPU utilization, and then finally create alarm. Okay, so let's go back to our first group for the increased group size and select Create a Simple Scaling Policy. And let's just say that we're going to add 2 instances whenever this alarm goes off. Let's go down to the same link under Decrease Group Size, Create a Simple Scaling Policy, and let's say remove 2 instances whenever this alarm goes off. Finally, let's just click on Review and then Create Auto Scaling Group and close. Okay, we now have our auto scaling group. If we go check our EC2s, there should be 2 more launching. And here they are. Now let's go under our load balancer. And after a few minutes, you should be able to click on the Instances tab and see the 2 instances in service behind the load balancer. Now to complete this demo, let's go to the Description tab, copy our public DNS name for our load balancer into the clipboard, open a new tab, and there's our web page coming up on our instances that were launched by the auto scaling group behind the load balancer. This is the final section of our course on designing AWS environments. Congratulations! In this section, we covered classic EC2s and EC2s in a VPC, using the default VPC, creating your own VPC with the VPC wizard or from scratch, connecting to your VPC, and securing it with network ACLs, bastions, and NAT instances. Finally, we covered making your architecture highly available by using multiple availability zones, elastic load balancing, and auto scaling. For next steps, I suggest getting some practice with your free AWS account. Create some VPCs and launch applications on EC2 instances in them. Don't forget to implement best security practices and to make your application highly available. You may want to go back and review the demonstration videos in this course, pausing as needed. And finally, thanks for viewing our course and good luck using your new AWS skills.